Okay, so now we're going to be doing question 7c. Now this is a bit more abstract because it's asking us to consider a function g of theta equals sine theta minus theta cos theta, and to show that it's always greater than 0 for our domain of theta between pi and 0 by considering its derivative. So we'll get started by doing the derivative of this equation. So g dash or g prime theta. So the derivative of sine is cos theta. And the derivative of this, so this is another product rule, so we'll do the derivative of the first, which is 1, multiplied by the second, plus the derivative of the second, so that's minus sine theta, times the first. Okay, so now expanding and simplifying, so cos theta minus cos theta, plus theta sine theta. All right, these two cancel out because they're like terms, so we get 0, not 0, theta sine theta as the derivative. So how's this going to help us? Well, we need to now consider our domain of theta between pi and 0. Well, if we consider the graph of sine theta, so you can notice sine will go like this, and it intercepts at theta, at pi and 0. We realize that for this domain, sine theta is always going to be positive. And similarly, if you take y equals theta, that's going to be this. And clearly, theta also will be greater than 0 for all of that. So theta 2 is also greater than 0 for theta is greater than pi, less than pi and greater than 0. Okay, so if these two things are greater than 0 for that domain, then the product of them must be greater than 0 as well. So therefore, theta sine theta is always going to be greater than 0 for theta between pi and 0. Therefore, our gradient function is also greater than 0. So what does that mean in terms of the question now? Well, if you've learnt from like your inverse functions and your study of calculus, you'll know that if a gradient function is always positive, then the graph itself must be monotonic increasing. So for instance, we may have a graph that might look like this. As you can see, its gradient is always positive, so that means it's always increasing. So same case goes for our g of theta. If the gradient function here is always greater than 0, then our function must too be always increasing. But how do we know it's going to be greater than 0? Because it could always be increasing, but it could be below the x-axis or the theta axis, however you want to call it. So we're going to test when theta is equal to 0. So then we've got g of 0, so sine of 0, that's going to be equal to 0. 0 times anything is 0. So that means that our function has to go through the origin. So if it's always increasing, it must start from here and forever increase up to the point where we stop at pi, because that's where our domain's defined. So if it's strictly between 0 and pi, then we don't have to include this point. So therefore, we now know that our function must be greater than 0, because if you see here, it's always above our theta axis. So therefore, we have shown that g of theta is greater than 0 for theta between pi and 0.